Good morning, my dear students. In this particular video presentation, we'll discuss some problems from exercise 7.2 of class 12 on integration from NCERT textbook. Actually, the problems are coming under substitution method. The first problem goes like this: integral 2x dx by 1 plus x square. Practically speaking, what I should do is I should be able to, we should be able to realize the derivative of 1 plus x square is 2x. Therefore, what you should do is put t is equal to 1 plus x square. Now dt will be 2x dx. Therefore, integral 2x dx by 1 plus x square can be written as integral dt by t. My denominator is t, which is nothing but log mod t plus c, which is log mod 1 plus x square plus c. I have an easy method to do. I'll just tell you, listen carefully. Anyway, I need to know what is my substitution. I can write the numerator as d of 1 plus x square by 1 plus x square. Since d by dx of 1 plus x square is 2x, just cross multiply. I'll get 2x dx is d of 1 plus x square. Now have this in mind to be my t, dt by t, where t is 1 plus x square, which will be nothing but log mod t plus c, which is log mod 1 plus x square plus c. This will have continuity of steps. Let me just explain once again. I need to have the observation derivative of 1 plus x square is 2x dx. Therefore, I use the substitution t is equal to 1 plus x square. dt becomes 2x dt. Now for here the numerator becomes dt, denominator becomes t. Integral dt by t is nothing but log mod t. But my final answer has to be in terms of x, therefore it is log mod 1 plus x square plus c. Instead, I can write this 2x dx as d of 1 plus x square. See here, you can write since d by dx of 1 plus x square is 2x, cross multiply dx, 2x dx can be written as this. You can close this and find out this is my substitution. Therefore, I can write this as dt by t, but t is 1 plus x square. Therefore, log mod t plus c is log mod 1 plus x square. Anyway, you need to know what your substitution is, which will be done in an easier way like this. Let me do the second problem. He says log x the whole square by x dx. Now you have to have a clear observation. Derivative log x is 1 by x. Therefore, I will just group dx by x together. Therefore, I will be able to write this as d of log x. Since the reason is d by dx of log x is 1 by x, you know very well. Therefore, dx by x is d log x. Now, put this in mind. You can close this and find out. This is my t. Therefore, this can be written as t square dt, where my t is log x. Now, this is reduced to t cube by 3 plus c, which is log x the whole cube by 3 plus c, or log cube x, log x whole cube, both are same. I repeat the whole process. I am applying the second method. This method I am applying here. I'll be able to recall derivative of log x is 1 by x. I am grouping dx by x in the second step. Dx by x can be written as d of log x. If I write d by dx of a quantity, etc., of a function, etc., it's called derivative. If I write d of, it is called differential coefficient. I should be able to write the corresponding differential coefficient of the substitution I am going to use over here. See here, d by dx of log x is 1 by x. Cross multiply dx by x is nothing but d of log x. Close this and find out. Now for I have to replace this by t. Now for it's of the form t square dt by t is log x. Integral t square dt is t cube by 3. Now for log x whole cube by 3 plus c is the final answer. Log x whole cube by 3 is the final answer. Log x the whole cube plus 3 is the final answer. Okay, it's not a big deal. I'll just move on to the next problem. I'm just applying the second method. Some of you may feel that it is difficult. It is not at all difficult. In both the methods, I should definitely know what my substitution is. In both the methods, we should know what the substitution is. Therefore, the second method is practically speaking an easier method. See here, third one, integral dx by x plus x log x, which is what I will do is I'll be able to take x as common here, 1 plus log x. You should have a clear observation. D of 1 is 0, d of log x is dx by x. Therefore, I will write 1 by 1 plus log x in together and dx by x together. Now I will write this as 1 by 1 plus log x into d of 1 plus log x. Just since d by dx of 1 plus log x is simply 1 by x. D of 1 is 0, d of log x is 1 by x. Cross multiply dx, dx by x can be written like this. Now close this off and imagine this as t. This is the form integral dt by t, where what is my t? T is 1 plus log x. Integral dt by t is nothing but log mod t plus c, which is log mod 1 plus log x plus c is the final answer. We just repeat. Integral dx by x plus x log x. I'll be able to take x as common in the denominator, and I'm able to recall d of 1 being a constant is 0, d of log x is dx by x. I'm grouping dx by x. This dx by x can be written as a differential coefficient as d of 1 plus log x. See here, d by dx of 1 plus log x. Derivative 1 is 0, derivative log x is 1 by x. Cross multiply dx, dx by x can be written as d of 1 plus log x. Close this off with your hands. I can find out this is my substitution. It's with the form dt by t, where t is 1 plus log x. dt by t, where t is 1 plus log x. Therefore, it is nothing but log mod t plus c. Therefore, log mod 1 plus log x plus c is the final answer. It is not at all difficult to follow. It's an easy way to write. All of you, please practice this. It is always easier. Such a method is easier for you to apply in 6 marks, 5 marks, sums, etc. Now, sin x into sine of cos x dx, that is a question given to you. Now, derivative cos x is nothing but minus sin x. Therefore, I will multiply two minus sines and I'll take this minus sin x dx together. Listen carefully. Therefore, I'll be able to write this as sin x cos x into d of cos x. In very well outside you can write d by dx of cos x is minus sin x. Cross multiply, I'll get minus sin x dx is nothing but minus sin x dx is d of cos x. Now close this off and find out. This is my substitution now. Therefore, it is of the form minus sin t dt, where my t is cos x. Now I end up with simply integral sin t is integral sin t, or integral minus sin t is nothing but minus of minus cos t plus c. You can just verify. Therefore, this reduced to cos of cos x plus c is the final answer. Cos of cos x plus c. Let me just verify. You are given sin x sin cos x dx. Derivative cos x is minus sin x, you know very well. Therefore, multiply two minus sines, and minus sin x dx can be written as d of cos x. See here, d by dx of cos x is minus sin x. Cross multiply, minus sin x dx is nothing but d of cos x. Now, I have to close this off with my hands and I should be able to find out this is my substitution automatically. Now, for minus integral sin t dt, where t is cos x, this is my substitution now. Minus sin t dt, the integral is minus cos t. Derivative cos t is minus sin t. Therefore, the whole thing gets reduced to cos t, and replace t by this substitution. T is cos x. Therefore, cos of cos x plus c is the final answer. Cos of cos x. You can easily verify. See here, You can differentiate this and find out. Here it is minus sine cos x into, again I have minus sine x. It makes it a plus sine x into sine cos x. Differentiating this, I'll be able to observe that my function by which I started with, I'll get. By differentiating the final answer, I should be able to get the given function. That is how it is being done. That is how it is being done. It's not a difficult task to follow. Now, for apply the second method, you practice as many sums as possible. Definitely, you'll be able to follow. Practice as many sums as possible. You'll be able to follow. Just shall do just one more problem. See here, fifth sum. Integral sine ax plus b into cos ax plus b dx. This can be done in two different ways. Just recall, derivative of sine ax plus b is a cos ax plus b. Now for multiply and divide by a here, I can very well write this as sine ax plus b into a cos ax plus b dx here. This can be written as 1 by a sine ax plus b into d of sine ax plus b here. Just recall here, d by dx of sine ax plus b is equal to a cos ax plus b. Just cross multiply dx, I'll get a cos ax plus b can be written like this. Close this off and find out. Close this with your hands. This is my substitution. Now for 1 by a integral t dt, where my t is sine ax plus b. Therefore, I end up with 1 by a into t square by 2 plus c, which is anyway sine square ax plus b divided by 2a plus c. The same thing can also be done as sine ax plus b into cos ax plus b dx can be written as minus 1 by a into integral cos ax plus b into minus a sine ax plus b dx. This can be written as minus 1 by a into cos ax plus b into d of cos ax plus b. You can write in brackets outside d by dx of cos ax plus b is minus a sine ax plus b, and cross multiply dx. Close this off. This is my substitution t now. Now for minus 1 by a integral t dt, where my t is cos ax plus b. Therefore, this is minus 1 by a t square by 2 plus c, which is minus cos square ax plus b divided by 2a plus c. Let me explain both the methods once again. Here I am going to use sine ax plus b as the substitution. Therefore, my derivative is a cos ax plus b. Multiply and divide by a in the second step. This is replaced by d of this. Therefore, d by dx of sine this a cos ax plus b. Replace this by t dt is t square by 2. Therefore, sine square ax plus b by 2a is one of the formulae. Now here again, sine ax plus b into cos ax plus b. I am going to use cos ax plus b as my substitution. The derivative is minus a sine ax plus b. Therefore, multiply and divide by minus a. Minus 1 by a integral t dt, where t is this much. Here you can write in brackets outside as done here. Minus 1 by a t square by 2 plus c. You can easily verify both are same, because this can be written as 1 minus sine square ax plus b. Therefore, minus of minus sine square become plus sine square, and this constant minus 1 by 2a plus c can be replaced by another constant c1. Therefore, both are ultimately the same. Both will be the same. The same can also be done in a different way. I'll explain once again. Don't get confused. It's better for you to understand the different method, so that if the question is given, show that you should be prepared for that. See here, this is given as sine ax plus b into cos ax plus b dx. Just multiply and divide by 2. 2 sine ax plus b into cos ax plus b dx. Therefore, here I mean to say sine 2ax plus 2b. 2 sine a cos a is nothing but sine 2a. Here I will be able to write it as minus cos 2ax plus 2b by 2a plus c. This is anyways equal to minus cos 2ax plus 2b divided by 4a plus c. And you can even equate it to this format using formula of cos 2a. All the three can be equated using a suitable trigonometric formulae. I repeat, multiply and divide by 2 in the second step. 2 sin a cos a is nothing but sin 2a. Therefore, sin 2ax plus 2b. The integral here is minus cos 2ax plus 2b by 2a. Okay, here because in the derivative, I'll get it to be minus sin 2ax plus 2b into minus 2a. Therefore, this is minus cos 2ax plus 2b by 4a. And here again, using a suitable cos 2a formula in terms of cosine, I'll be able to equal to the same thing can be equated to this. For all the three are correct. It is almost 15 minutes. I'll do the rest in the next video. Thank you students for patient watching, and if you feel that it's really good, share with your friends and relatives and persons known to you, and you can advise them to subscribe by clicking the subscribe button and bell icon. Subscription has no charges. Thank you.